let's discuss the electron configuration of the following elements. We have hydrogen, atomic number 1, it means 1 electron, helium 2, lithium 3, beryllium 4, and boron 5. So the electron configuration of hydrogen is 1s1. Then for helium, we have 1s2. Then for lithium, it has 3 electrons, so that's one more compared to helium. So we have 1s2, then we just add 1. And again, it's on the next level, we have 2s1. So as you observe here, the first part of the configuration of lithium is the same of that with helium. So we could actually write this one as something like this. So again, the first part is the same with helium. So we write here the helium in brackets. Then again, we have one more electron on the 2s1. We have helium 2s1. So this one is the shortcut method for writing the electron configuration of lithium. We could do the same thing for beryllium, that is 1s2, 2s2, because again, we have 4 electrons. Again, the first part is the same with helium, so we could just write this one, helium, then we have 2s2. Then for boron, we have 1s2, 2s2, 2p1. Again, the first part is the same with that of helium. Then again, the next part, we have 2s2, then we have the 2p1. So we call this one, by the way, this one is called as the noble gas notation. So in this case, we use the noble gases. So this one over here, this group, the last group on the table of elements, we call this group as the noble gases, and they are used on this notation. So let's proceed to neon. So neon has an atomic number of 10. It means 10 electrons. So the electron configuration of neon would be 1s2, 2s2, 2p6. So that's 4, 10. This is the electron configuration of neon. The next element is sodium, so that's 11. So that's one more electron compared to neon. So again, just copy the first one. That's 10, but again, we have 11. So let's add one more electron, which will go to the next energy level, which is on 3s1. And again, we could do a shortcut for this. Again, the inside is the same with neon. We have neon over here. Then we have the next is we have the 3s1. Okay, so this one is the noble gas notation for sodium. Before we continue, let's discuss the different patterns on the table of elements. So here are the different blocks of the table of elements. We have the S block, we have the P block in green, we have in purple or in pink, we have the D block, then we have for orange, yellow, something, we have the F block. So in this case, all of the elements on the S block, including this one, their last sublevel configuration is on the S sublevel. So for example, for lithium, we have 1s2, 2s1. So in this case, as you see here, the last sublevel or the last part is on the S sublevel. Let's do the same thing for sodium. So that is 1s2, 2s2, 2p6, 3s1. So again, the same thing is on the S sublevel. The same is true for the other blocks. For example, we have boron, that is 5 electrons, 1s2, 2s2, 2p1. So again, the last sublevel is on the p sublevel. Also, there are different patterns here. For example, we have the different periods over here. This is the first period. So the periods are the horizontal rows on the table of elements. We have 7. This is period 1, period 2, period 3, we have period 4. Again, we have period 1, 2, 3, 4, 5, 6, 7. So for example, we have for lithium, it's on the second period. So as you can observe here, for the electron configuration of lithium, we have 1s2, 2s1. So it's on, so yung last na main energy level on the configuration, it's on the second energy level. Then the same is true for the sodium over here. We have 1s2, 2s2, 2p6, then we have 3s1. So again, it's on the third energy level. So it's the same thing. So we have the first energy level, second, third, fourth, fifth, sixth, seven. Then the same thing for this, except for this one over here. As you observe here, it started with the third energy level, then we have fourth, five, six. So just take in mind of this difference. But again, for the rest, just follow the period number on the table of elements. So we'll explore more of this as we go on to the different examples. So let's go to magnesium. So magnesium is again over here. It has 12 electrons. That's 2 more compared to neon. Again, on this case, the closest noble gas before magnesium is neon. We have Na over here. And then from this one, just count how many steps. So again, this one is on the, sorry, 4, 5, 6, 7. This one is on the third period. So on this case, the last part is on the third energy level. So in this case, 3s1 for sodium, so magnesium will be 3s2. Okay, so that's the last configuration is on the 3s level. Let's proceed to our aluminum. Aluminum has atomic number 13. It's over here. So again, the closest noble gas is neon, so that's neon. And again, let's add the others. So again, from this one is on the third energy level on the S block. So this one is 3s1, this is 3s2. So 3s2, and after 3s2, this one is the P block over here, and again, it's on the third period. So this one is on the P1. Again, this is P1, P2, P3, P4, P5, P6. So since this one is on this one, so this one is 3p1. Okay, this is the noble gas configuration for, or the noble gas notation for aluminum. Next, we have silicon. Silicon is over here. So the same thing, we have neon. Then from neon, let's add the rest. We have 3s1, 3s2. So 3s2, after 3s2, we have this one. We have 3p1, then 3p2. Okay, 3p2. Then let's go to phosphorus. We have neon again. It's the closest noble gas. We have 3s1, 3s2. Then here we have 3p1, 3p2. This would be 3p3. Okay, so this is the configuration of these elements. Let's proceed to the last one.